In this video, I'm going to discuss and introduce the charge polarization. But before that, in previous video, I missed one concept I wanted to share. So let me just share that first. Here. So you see the lightning happens. The cloud is a bunch of water molecules, ices. Waters are conductive. So when lots of ices piles up and you're starting to have some separation, induction in electric charge, because the surface of the ground is slightly positively charged. So we always have a ground that's slightly positive charged, and then you have a cloud on top. So the negative, the bottom of the cloud is negative, and top of the cloud becomes positive. So charge is induced. And when this induction induced charge becomes bigger and bigger and bigger, right, as the more and more water molecules gets condensed, then at one point, although the air is dielectric, which means in insulator. Air is typically in an insulator, but you sometimes see this dielectric breakdown that it leaks out from here and then it just shuts down and goes into the ground. So that's the lightning. You notice that whenever I was drawing those charge distribution, especially in a metallic surface, when I put the rod, the positively charged or negatively charged object and move away, once the charged object move away, charged object is going to have those conductive charged object is going to have a charge that's always stays on the surface in a nicely uniform way. Because if the same charges, they don't like each other, so they find a good spacing away from each other. But that's only for the case of the sphere. When you have a conductive surface like this, that has a non-nice shape, some of them is like pointy, and some of them is flat. So when you have a pointy objects, we're going to do this a little bit more later, but if you have a pointing object, charges likes to accumulate and goes more to the pointy side. And in a flat, they go away. So when you have a charged object with the pointy shape, conductive pointy shape, it charges tends to go to that pointiness. So the negative will go most likely into this tall, the closer to the minus cloud, and then pointy shape. What's that? What's this called? Lightning rod. So that's one concept that I wanted to discuss. But here in this video, I want to introduce you polarization. And remember, I keep showing you the same video, but here's the video of that tissue paper is being attracted by the negatively charged balloon. So here, I borrow his head and then using a friction, the balloon is negatively charged. And then these tissue papers are neutral. And what kind of a material are these tissue papers? Insulators, right? No conductors. And you see these insulator materials are being attracted and it just even goes up. It can't stand it. It wants to go so much to the balloon and it gets attracted. But what is it? The tissue paper has no free electrons. It's not conductors. And then how does this balloon attract these tissue papers that's non-conductive material? So tissue paper Oops, sorry. They're insulators. Let's see, we can have a red balloon. And this red balloon has a negatively charged balloon. And we saw the tissue papers. Being attracted. And this is non-conductive insulators. No free electrons. But it likes to be attracted so much. So here is the charge polarization. This you can see in a dielectric material. So no free electrons. Let's see. So typically, let's say this is the nucleus of the atom. And around the nucleus, we have electrons. Let's say it's in a symmetrical shape. Material has a bunch of these atoms with a symmetrical shape. What happens when we bring, let's say, it could be positively charged object or negatively. Let's see here, we have a positively charged object nearby. Then I have had this positive nucleus, positively charged nucleus, and the negatively charged electron clouds are going to be still attracted to the external force, positively charged object. It cannot go move out from the atom. It's still bounded to the atom, but it's still attracted. So instead of having initially the nice spherical shape, nice symmetrical shape, now E minus is going to be on the one side. So this is called no longer it's symmetrical. Now we say atoms are electrically polarized. You see, it's being separated. So inside the atom, plus is going one side and the minus is going other side, not in the material. But you see that all these atoms that's polarized is making up a material, insulator material, like a tissue paper. So we have a positive, 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 positive. And then we still have electrons bounded to the atoms or molecules, but all these electrons are on the one side, biased by the external force. So this object, the positively charged object, induces, induced polarization. charge polarization. Let me see. This might be better view. So here, A is the when typically there's no external force applied. So you have a positive nucleus in the center, and negatively charged electron clouds are making a nice spherical shape. But let's say when you have an external, in this case, negatively charged nearby to the right. So this side you have a negatively charged one. Then the nucleus is going to be attracted. Positively charged nucleus is going to be attracted to the right. And then the negatively charged cloud is going to be repulsed to the other side. So individual atoms are polarized. Atoms are polarized, and overall, the surface, one side of the surface of the material becomes positively charged. On the other side, it's going to be negatively charged. So it is not that charges move away in the entire surface, but individual molecules are change its shape and biased by the external force to be polarized. So why does balloon stick to the wall? Why does the tissue paper is being attracted, right? So instead of this could be a balloon or it's hair comb. Hair comb is going to be positively charged. And then a tissue paper, this is not 100% correct visualization, because it's not that a minus charge moved all the way to the one side, but individual atoms and molecules here is being polarized. And you add up all those plus and minuses, then you're going to have one side to be negatively charged and the other side to be positively charged. So atoms arrange its shape to have one side to be negative, the other side to be positive, without having a free electrons. So that's why we saw all the tissue papers being stuck to the balloon really well, right? And the balloon will stick to the wall. Negatively charged balloon will stick to the wall. Even the wall is an insulator. All right. So that's why the balloon is gonna stick to the wall, to the insulator wall, because all these molecules here is gonna make a rearrangement in the shape. The overall it looks like there is the charge that's being induced on one side and then negative on the other side. And this is called polarized. So what happens if the balloon touches metallic surface, like a doorknob that's made of metal? Then what happens to the balloon now? This negatively charged, initially charged balloon, this negative will flow into the metal, because the metal has the free electrons. So you can just move the electrons. Electrons can move freely, and it goes to be, it's drained. It goes to the ground. And it falls out because it loses its charge. Charge will go into the conductor, and then it loses the charge, and then it flows down. Some materials are naturally electrically polarized. So, for example, water, H2O. So H2O has obviously 2 hydrogen and 1 oxygen, but a shape. So you have a 1 oxygen and a 2 hydrogen. And the shape of a H2O is like a Mickey Mouse. You have a little ear. And then this each H has a plus, and then O has a 2 minus. That they share the electrons, 2 minus and a 2 plus. So you see that there is going to be a positive on one side and a negative on the other side. And it has some spacing in between. So water is naturally polarized. And then whenever you have a positive and negative as a pair, this is called electric dipole. When you have a plus on one side and a negative on the other side. That's called electric dipole. How does the microwave work? Microwave is to heat up your food. So most of the food has water in it. Water, these Mickey Mouse in it. So one side of the microwave is positively charged and the other side of the microwave is negatively charged. Then you put the food inside, turn on, then positively charged, negatively charged. Boom. The molecules in the water molecules in the food flip. They're polarized, so it moves. Now let's change the positive side to the negative and then negative to plus. So the molecule flips, change, flips, flipping. That becomes raise its kinetic energy and raise its temperature. So microwave uses this property, electric dipole, or the polarization of the water molecule that's naturally, it's polarized. We use that nature to heat up the food because all the food that has the water. Okay, so that's all I want to say about the polarization. Yep, that's it for the polarization, and I guess I'll see you in the class.